Okay, so our today's topic is chemical kinetics. Chemical kinetics, we will take these topics: rate of reaction, factors affecting rate of reaction, rate law, methods to determine rate law, and methods to meter the progress of reaction. Then effect of temperature, that is Arrhenius equation, reason theory, effect of catalyst, and then determination of rate law and order with of mechanism. And then last topic is sequential, parallel and reversible first order reaction. These are the complex reactions. So rate of reaction, as you know, rate of reaction means change in concentration or pressure of reactant or product with respect to time, and its unit is mole per liter, mole per second. That means mole per liter per second, or if pressure is in atmosphere, then it is atmosphere per second, or if it is measured in bar per second, or if it is measured in of Hg, then Hg per second. These are the units of rate of reaction. Now average rate means total change in concentration to the time taken, and that is called average rate of reaction, and it always comes out to be positive. That's why when we have reactant to product, we will put negative sign before the change in the concentration of reactant to make the rate of the reaction positive, because it is minus delta R by delta T or plus delta P by delta T. Because you know, when we have reactant to product and at time, initial time, let us say T1, concentration of reactant is R1 and concentration of product is P1. So at time T2, concentration of reactant is R2 and it is P2, and you know, reactant R1 is always greater than R2 and P1 is always less than P2, because product is increasing, reactant is decreasing. That's why, you know, change in concentration of reactant is final minus initial, that is always negative, and delta P is P2 minus P1, that is always positive. In this way, we put a negative sign before the change in concentration of reactant, so that rate of reaction is positive, minus delta R by delta T or plus delta P by delta T. And slope of the concentration of the reactant changes with time. So this is exponential change, and the slope of the curve is the rate of reaction. That is for instantaneous rate of reaction when limit delta T tend to 0, is at particular instant of time. So instantaneous rate is as minus dr by dt or plus d by dt. In case of product, now it is increasing gain and is product at initial time, product at final time, rate is equal to 2 minus P1 upon P2 minus T1. Initial rate of reaction means when we take the concentration at initial time. Time is 0. And if we have this type of reaction, A moles of A plus B moles of B gives C moles of C and D moles of D, it is equal to minus 1 upon A dA by dt minus 1 upon B dB by dt plus 1 upon C dC by dt and plus 1 upon D dD by dt. Now, the factors affecting rate of reaction, main factors are concentration, temperature, presence or absence of a catalyst, nature of reactants, pH of the medium, pressure inside the reaction container, dielectric constant, even dielectric constant of the solvent, that will change the rate of reaction. Some reactions takes place in the presence of light only. Even electric or magnetic field also affect the rate of reaction when they are charged, or we are dealing with polar molecules. There are so many more factors as well, but main factors are concentration, temperature, catalyst. These three factors are main factors which affect the rate of reaction. So for most of the reactions, rate is proportional to concentration raised to power order. And order is the sum of the powers to which concentration terms are raised in the rate law expression, and it is an experimental figure. A rate is equal to rate constant to concentration of reactant raised to power order, and this is called rate law, where K is that rate constant or specific reaction rate, or it is also called velocity constant, and this K is the rate of reaction when concentration is taken as unity. When we take concentration as 1 molar, then the rate of reaction is called rate constant. That's why it is called specific reaction rate. We specify the concentration as 1 molar. K depends on temperature only. It is independent of the concentration. Keep in mind, it is important. K depends on temperature only. And unit of K. So K is equal to rate divided by concentration raised to power order. So what is rate? In concentration per unit time. Unit is concentration over time, and it is concentration raised to power order. So if order is taken as N and concentration as mole per liter, it is mole per liter raised to power 1 minus N, and time in second, so per second. So for zero order reaction, N is 0. So unit of K is mole per liter per second. For first order reaction, N is 1. So unit of K is per second only. And for second order reaction, N is 2. The unit is per mole liter per second. For third order reaction, N is 3, and it is mole minus 2 liter 2 per second, and so on. So in this way you can figure out the constant unit of K depends on the order of the reaction. Can be written as mole raised to power 1 minus N, liter raised to power N minus 1 per second. Order of reaction is the sum of the powers, exponents of all the concentration terms appearing in the rate law expression. For example, if we have K equal R equal to K and 2O5 raised to power 1, it is first order reaction. This is K Br negative raised to power 1, BrO3 negative raised to power 1, H2O raised to power 1. Here is CO raised to power 0. This is experimental, okay? Rate is determined, rate law expression is determined experimentally. It is independent of concentration of C. This first order reaction. It is again first order 2 minus 1. This is zero order reaction. Order is fractional. Order can be fractional or even negative. This third order reaction. Now zero order reaction. The zero order reaction, rate is equal to K A raised to power 0. It is independent of the concentration. So if we plot a graph in rate versus concentration, so it is constant, its value is equal to K. This is K and it remains K even if we change the concentration. It is independent of the concentration of reactant, and expression is concentration at time t, that is equal to initial concentration at time t equal to initial concentration minus Kt. That means if we have A minus X equal to A minus Kt, what is X? X is equal to Kt. So if we plot a graph between and slope is K, because it is just like y equal to mx. X and t are variables. Same when we plot a graph between Ct versus T naught, Ct versus T, then as time increases, T decreases. Minus. Integrated rate law for X equal to Kt graph is Ct versus time. See this one, at this point time is 0. So this is C naught. Here Ct is 0. When Ct is 0, time comes out to be, when Ct is 0, time is equal to C naught by K. That's why this is C naught by K. In this graph touches time axis at C naught by K and concentration axis at C naught. Rate versus time, plot a graph that is straight line independent of the time, independent of the concentration. Concentration is independent, Obviously it is independent of time. Now if we calculate the time taken for the completion of the reaction, so keep in mind only reaction which can be completed is zero order. All the other reactions take infinite time to complete it. If it is not time taken for completion of reaction, if it is not zero order, it will take infinite time, means it will never complete. But there is only one reaction which can be completed, that is the zero order reaction. So for a zero order reaction to be completed, that means the reaction is completely consumed, is Ct is 0. So in that case, time for the completion of the reaction comes out to be C naught by K. It's also important. Now half-life. What is half-life? The time taken for the reaction to be consumed or to be decreased to half of its initial value. That means Ct comes out to be C naught by 2, and therefore when time is T half, Ct comes out to be naught by 2, and T half is equal to T naught by 2K. That means T half is directly proportional to initial concentration. That means if we plot a graph in half-life of zero order reaction versus initial concentration, is a straight line. The slope equal to 1 by 2K. Whenever half-life and C naught are plotted for zero order reaction, starts from the origin and straight line, direct relation is there, and therefore slope is 1 upon 2K. But it is when it is A2 product, simple reaction, A2 product. If it is like 3 A2 products, see, whenever we have, instead of A2 product, it is 3 A2 products, again zero order reaction. Then see, for A2 products, you know, Ct was equal to C naught minus Kt. But if it is 3A2 products, then it is Ct equal to C naught minus 3Kt. Also important. See, this is a complete derivation. Ct comes out to be C naught minus 3Kt. If it is 3A2 products for zero order reaction. Now, if reaction is like A plus 2B, there are two different reactants having different stoichiometry. 1 mole of A react with 2 moles of B, the product. So, calculate half-life of A, half-life of B, and concentration of A after time t, concentration of B after time t, and also find the conditions on A and B when half-lives of A and B will be equal. If this is the question, how do you start? You start with the reaction given, that is A plus 2B to give products. At time 0, you know, reactant A, capital A, has concentration small a, reactant B has concentration small b. So after time t, let us say x moles of A are reacted. So when x moles of A are reacted, amount of A left unreacted is A minus X. So if X in A plus 2B, if 1 mole of A reacts, then at the same time it reacts with 2 moles of B, and that's why if it is A minus X, it is B minus 2X. So say it has only 1 mole, it has 2 moles. So when we calculate the half-life of A is simply as A2 products, but for B, because it has 2 moles, and its half-life is B divided by 4K, because now concentration of B after time T is B minus 2KT. Same here. See, calculate half-life of this reaction. Tell me, what is the value? E naught divided by, yes beta, what is half-life of this reaction? E naught by so what is half-life of this reaction? It is C naught by 6K. Okay. Same here, it is B minus 2KT, that's why it is B by 4K. What about this? What is half-life of this reaction? Ct for this reaction is C naught minus 5 by 2 KT. So it is 5 by 2 K into 2, C naught by 2 into this. So it is C naught by 5K. Got it? It is C naught by 5. It is C naught minus 5 by 2 KT. It is C naught by 2 comes out to be. No need to write all this. Just keep in mind that T half is equal to C naught divided by NK, N 2 NK. For Na2 products for zero order reaction. That decomposition of Cl2O7 gas to ClO2 gas plus O2 and O2 gas is a zero order reaction. If at a particular time minus dCl2 7 dt is equal to 50 mm of Hg per second, for the decomposition reaction having initial pressure of Cl2O7 as 600 mm. Calculate the rate of production of O2 at time 2 seconds. Calculate half-life for the reaction of Cl2O7. Calculate the rate of reaction for particular reaction Cl2O7 with 4ClO2 plus CO2 at this instant. What is the total pressure after 10 seconds, initially ClO2 and O2 were absent. First of all, you know, reaction dO2 by dt. This C, take this reaction 2Cl2O7 to give 4ClO2 plus 3O2. So here, what is the rate? Minus half dCl2O7 by dt equal to plus 1 by 4 dClO2 ClO2 by dt plus 1 by 3 dO2 by dt. In this way, dO2 by dt comes out to be minus 3 by 2 dCl2O7 by dt. That's what written dO2 by dt is minus 3 by 2 dCl2O7 by dt. Value is given 50, comes out to be 75 mm. Rate of production of O2. Now T half. T half means, now what is the dCl2 by dt is given T half is C naught. Instead of C naught we write E naught, and this is equal to, because it is a zero order reaction, it is equal to K Cl2O7 raised to power 0. So it is given zero order reaction. This is equal to K. So in this way, you know, minus dCl2 by dt is given 50. What is K? K comes out to be 25. K divided by 2 into 50. 600 is P naught, right? What is T half for zero order reaction? Naught by 2K. Naught by and minus dCl2 by so they say it is 2. So it means comes out to be 4K. Got it? See this one 2nk E naught by 2nk. So here, because it is 2n is 2, so it is 4K, and C naught is C naught means instead of C naught we take P naught on 4K. 4 to 25 comes out to be 6 seconds. You can take 2 into 50 or 4 into 25, because when you have this relation, so K is equal to 50 by 2, that means 25. And next is rate of the reaction is minus half dCl2 7 by dt 25 mm of Hg per second. Next is total pressure. So this is the relation. At time 0, take pressure as P naught, and that value of P naught is 600. So initial pressure of Cl2O7 is taken as 6 P naught, time t, P naught minus 2x equal to 4x Tx. Because if 2 moles of Cl2O7 decompose, we get 4 moles of ClO2 and 3 moles of O2. P naught minus 2x, 4x Tx, and in this way, total pressure comes out to be P naught minus 2x plus 4x plus 3. But it is given that minus dCl2 by 7 by dt is 50 mm of Hg after some time. So comes out to be, talk about total pressure, P naught plus 5x amount reacted of Cl2O7, that is 2x is equal to 80, so 2x equal to 80 plus 10, that is x comes out to be 250. This way P naught plus 5x is 600 plus 5 into 250, 18 mm of Hg. That is the total pressure. Order of reaction can be 0 in many different ways, like rate equal to K, A raised to power 0, B raised to power 0, C raised to power 0. But if nothing is mentioned, even CA2 product, and then rate is equal to K, A raised to power 0. But if nothing is mentioned, you will take it in this way: A products and rate equal to K, A raised to power 0. Now in case of first order reaction, this is the relation: natural log of Ct equal to natural log of C naught minus Kt. It is on the similar line as zero order. Zero order is Ct equal to C naught minus Kt. Just we add natural log in first order. Rest is same. Ct equal to C naught minus Kt for zero order, and natural log of Ct equal to natural log of C naught minus Kt for first order. As it is Ct equal to E naught to E raised to power minus Kt, because if we write it just inverse it, it comes out to be minus Kt. Ct by C naught equal to E raised to power minus Kt. This way Ct is equal to C naught into E raised to power minus Kt. These are the three relations: natural log of Ct equal to natural log naught minus Kt, Ct equal to C naught E raised to power minus Kt, or natural log of C naught upon equal to Kt. If we plot the graph of natural log of C naught by Ct. Ct by C naught, then plot a graph between natural log of C naught by Ct. It is like this. Slope equal to K, C naught by Ct. Straight line passing through origin. Now, if we plot Ct versus time, so concentration exponentially decreases, and if we plot X versus T, amount of reactant consumed, that is increasing, reaches a maximum value of A, that is the initial concentration of the reactant. And if we plot a graph between reactant versus time, rate decreases continuously. The time, because is minus dA by dt, that is equal to kt, to rate. Rate is decreasing with time. That's why it takes infinite time to complete the reaction. For zero order reaction, rate was like this. Rate is uniform even if concentration is decreasing. Now calculate the time taken for completion of reaction. So say in case of zero order reaction was finite, value was finite. Was C naught by K. This case, time taken is, because rate exponentially decreases, that's why it will take infinite time for completion. Time taken for the reaction to complete finite. And for 50%, that natural log of 2 by K, 0.693 upon K, because time equal to 1 upon K natural log of T naught by T3. So for 50%, that T half, concentration is half of its initial value. Therefore, half life equal to 1 upon K natural log of naught by 2 comes out to be natural log of 2 by K, or 0.693 upon K. So half life is independent of initial concentration. So in this case, if we plot a graph between half life and initial concentration, the straight line independent of the initial concentration. This value is 0.93 by K. It depends on K only. As K increases, half-life decreases. K increases by increasing temperature. When temperature increases, half-life decreases. Half-life is independent of initial concentration. And even time taken for any percent completion of a first order reaction is also not dependent on the initial concentration, because it takes the ratio. Okay. See, for zero order reaction, the time taken for equal amount of reactant is equal. See, if we start with 100, then after 10 seconds, if it is 90, then next 10 seconds it becomes 80, next 70, next the way for zero order reaction is subtracting. But in case of first order reaction, if in 10 seconds it becomes 90, that means 10% decrease. Here we see the percentage is same. Percentage completion will require equal time. 90%, 90, 10% of 90 is 9, comes 81. And again, the decrease of 10% of 80, 10% of 72.9. So half-life of a first order reaction is constant, and therefore concentration remaining after n half-lives is every time it becomes half, T naught by 2n. That is the concentration of the reactant left after n half-life, not by T naught divided by 2 raised to power n. Now, if we have again 3A2 product and rate follows first order kinetics, calculate the half-life. Now CT becomes T naught e raised to power minus KT, instead of minus KT becomes minus 3 KT. And half-life natural log of 2 divided by, instead of K, now it becomes 3. For the reaction, we have 2A plus 3B2 product. A follows first order kinetics, B follows zero order reaction. So overall it is a first order reaction, but there are two different reactants. Calculate the half-life of A and B. For A, the case, rate is equal to A into A minus half of dA. dA by dt equal to minus 2AA, and overall for A, dt comes out to be E naught small a, initial concentration, to E raised to power minus A T. This way, it is A minus X, A into E raised to power minus T. X comes out to be A to 1 minus E raised to power minus, that is amount of A reacted after time T. Now for B, if X amount of A reacted, if 2 moles of A reacted then 3 moles will be consumed. For 1 mole it is 3 by 2. For x mole it is 3 by 2 x. A minus x, B minus dx by 2. Rate remains same, minus 1 by 2 dA by dt, and it is minus 1 by 3 dB by T equal to Ka. For B, dt is equal to B minus dx by 2, and x you know in same, A into 1 minus raised to equal to B minus dA 1 minus e raised to power minus 2 by is the concentration of B after time. Half-life of K is natural log of 2 by 2K. Is simple because it is a first order reaction with respect to A. But for B, it comes out to be 1 by 2A, natural log of 3A by 3A minus B. Because this is T. For this, dt was B minus dA by 2, 1 minus e raised to power minus 2. Here, take this B as B by 2. Take B by 2 will get dA divided by A minus, and B should be 10 dA. Then it is half-life of B 1 by 2K, natural log of dA divided by A minus B. See, in this case, coefficients of A and B are 3 and 5, and concentration is proportional. See, 3A and 5 means is same as the stoichiometric coefficient of A and B. Concentration is proportional to stoichiometric coefficient. In this case, if it is the case, then half-life of A as well as B is same, and that is also the half-life of the reaction. See, rate is minus 1 by 3 dA by dt minus 1 by 5 dV by dt. This way, dt comes out to be 5A e raised to power minus 5A by 3t, and half-life is 3 into natural log 2 by 5K, and that is same for all the reactants as well as reaction. See, if initial concentration of reactant is in stoichiometric ratio, half-life is same irrespective of the order. Examples of first order reaction is most common example. CO raised to power 0 and O2 raised to power 1. All the radioactive decays follows first order kinetics. Decomposition of Cl2O7 follows first order kinetics. H2O2 follows first order kinetics. ammonium nitrite to gas plus gas liquid, that is also first order. T 75%. First order reaction is independent of initial concentration. For first order reaction, 100 turns into 50 after one half life. It turns into 25 after second half life. Turns into 12.5 after third half life, and so on. TC is 50% completed. Here it is 75% completed. Here it is 7.5%. That means T 75% to 2 times T 50. For T 75% equal to 2 times T half. For T 75% is also written as 3 by 4. 75 over 100 times T half. And T 99.9%, that is equal to 100 times 10 times half. For first order reaction. Calculate T 0.75 over T 0.50 for a first order reaction. A 75 means 1/4 of C naught comes out to be the question from IIT for NEST I have taken. In a first order reaction, constant reactant after 30 and 40 minutes are C1 and respectively. What is the initial constant? For first order reaction, Ct equal to E naught e raised to power minus Kt, the formula. So after 30 minutes, E naught e raised to power minus 30k. After 40 minutes, E naught or minus k. E30 is C1 is C2. That implies that C1 by C2 equal to not E or minus A divided by not raised to power minus A. Not C naught cancel. E raised to power minus 30k plus 40. It is e raised to power 10k. E raised to power 10k equal to 1 by C2. Right? Calculate initial constant at time . Yes, but E1, let us put 10k, e raised to power 10k in one of the equations. See, it is E naught e raised to power minus 10k raised to power 3. for first equation. Is it okay? Write it like this. The C2 by C1 comes out to be e raised to power minus 10k, right? Are you getting it? Okay. So now instead of e raised to power minus 10k, just put this value. E2 by 1 raised to power t equal to c. You can put in first or second, up to you. Comes out to be not equal 1 into 1 by 2 raised to power t is 1 raised to power 4 divided by c. That means second option is correct. Just we have concentration of the reactant after 30 and 40 minutes, C1 and C2, initial concentration we have to find out. Can go like. Again question from ISER or ISER, yes. Half-life of a radioactive isotope is given. And you know radioactive first order kinetics. So time after which activity of the sample reduces 1 by 32 of its original activity would be. So half-life is given, amount left after and half-life is like this. N naught divided by 32, time after which 2 raised to power n equal to 32, that implies 2 raised to power n equal to 2 raised to power 5. N is equal to 5. 5 half-life. By 32 after 5 half-lives. 4, 8, 5 half-lives. After 5 half-lives, it becomes 1 by 32 time. And 9 into 5. Time is 5 times t half. That is 5 times 9 into 10 raised to power 4. .95 into 10 raised to power 5 years. Second order reaction. So in second order reaction, relation is 1 upon Ct minus 1 upon naught equal to Kt. See, for zero order it was Ct equal to T naught Ct minus C naught equal to minus Kt, right? For second one, it is natural log of Ct minus natural log of C naught equal to minus Kt. For third case, it is 1 upon Ct minus 1 upon C naught equal to Kt. Because in first two cases, Kt minus C naught equal to minus Kt. So in here it is 1 upon Ct, 1 minus 1 upon Ct to Kt, minus sign plus, because it is inverse now. It is zero order, first order, second order. It is 1 upon A minus x minus 1 upon A equal to Kt, or 1 upon Ct equal to naught plus Kt. If we plot a graph between 1 upon t versus t, it is a straight line, intercept 1 upon c naught and slope k. And if we plot a graph for naught minus ct divided by ct, t naught, the LCM naught minus ct kt, or c naught minus c divided by ct to k not t. K and c naught both are constant, and therefore we plot a graph with for c naught minus c divided by ct versus t. The straight line passing through region, and slope is k into, and half-life of this reaction, that comes out to be inversely proportional to initial concentration, is equal to 1 upon k into T naught. For nth order reaction, see, the first order, zero order reaction, half-life was directly proportional to naught. For second order reaction, dependent. For third order reaction is inversely proportional. That implies for nth order reaction, T half is to T naught 1 minus for nth order reaction, T half is not for 1 n. Okay. Half is for n minus 1, n minus 1 a. No need to remember this part. Please keep in mind this formula. Half-life is proportional to c naught raised to power 1 minus n, or firstly proportional to c naught raised to power n minus 1. Now again, if we compare zero first and second order reaction, for zero order reaction, if 100 amount converted to 50 in 10 seconds, half-life, and it is completed in 20 seconds. It is important to note. Zero order reaction, if its half-life is given, half-life is 10 seconds. So it is completed in 20 seconds. But for another reaction, either first, second, or so on, will take infinite time to. For second order reaction, CA2 product, Gate law is second order. A raised to power 2. What is half-life? Look at it. Half-life was 1 upon A in. What is half-life in this? Is 1 upon CKC naught, because now it is CA2 products. So the relation becomes 1 upon CT equal to 1 upon C naught. Instead of plus KT, now it is PKT, and that's why half-life is 1 upon pk. Again, if it is 2a plus 2b products, and it is second order with respect to a only, and 0 order with respect to b. So what is the concentration of A and B as a function of time? What is half-life of A and B? And conditions when half-lives are equal. That you know, what is the condition? Half-lives are equal. Ratio of A and B is actually A on B is equal to 2 by 3. Is ratio of A is to be 2 by 3 is if it is in the ratio of the stoichiometric coefficients and half-lives are equal. That is important condition. If number of moles are in ratio of their stoichiometric coefficients or equal to their stoichiometric coefficients, then their half-lives are equal. So relation is 1 upon Ca equal to 1 upon K plus 2 Kt for K. 1 upon x equal to 1 upon Kt, and to calculate, you have to calculate x from here. Then concentration of B minus Tx upon 2, because if 2 moles of A react, at the same time 3 moles of B reacts. 1 by 2 x by 2 x minus 3x by 2, and half-life again it is 1 upon A. Condition for equality of half-life is ratio should be now if we have two different reactants and rate depends upon both, first order with respect to A, first order with respect to B, and overall order of reaction is 2. This case will get this equation that you have to remember. Both the reactants are not same. Difference is Kt equal to 1 upon B minus A into x, B A minus x, and if write it like this, A minus B, then it is natural log B A minus x divided by A. Write in both ways, either write B minus A or A minus B. If you write B minus A, then it is A into minus x into divided by B into A minus x, and if you write A minus B, then it is B A minus x divided by A into, and if B is very greater than A, comes the case of pseudo first order reaction. So it looks like second order, but if B is very large, then B taken as constant. B minus A is taken as B, B minus x is also taken as B, and in that case equation like this. Now it becomes first reaction. B is taken as constant, large. That is called pseudo first order reaction. Reaction which appears to be of higher order but have to be of a first order. that is called pseudo first order reaction. Examples of pseudo first order reactions are the main example: hydrolysis of esters and hydrolysis of sucrose. They are pseudo first order reaction, and half life is means it behaves like first order and follow the first order kinetics. Here water is in excess. This case again water is in excess. Take concentration of water as constant. What is the concentration of water? Is taken as constant. K is multiplied by concentration of water. So what is the concentration of water taken? Is 5.55. Right? 5.55, because it is 1 gram per ml, 1000 gram per liter. 1000 gram is 18,000 by 18 mole per liter. Water is taken as 1 gram per ml, that is 1000 gram per liter. 1000 divided by 18, that is mole per liter, comes out to be 5.55 mole per liter. Again question from NEST. Composition reaction X2 3 studied at constant volume and temperature. For pure X gas starting material, first few readings of the observed total pressure P as a function of time given. Have X, T, Y. Initially, let us say 0 at time t 0. Now after 1 minute, T naught minus X is Px. Now what is total pressure after 1 minute? To partial pressure due to X plus pressure due to Y comes out to be P naught plus 2x. So total pressure after 1 minute is equal to 8 2x size 2x equal to minus 8 x is equal to 4. That implies X dy after 1, initially it was 8, after 1 minute it becomes 4, because 8 minus 4, that means half life of this reaction is 1 minute. Half life is 1 minute. Now what about next? After 2 minutes, let us say now it is P naught minus X dash, P X dash, again total pressure now is P naught plus x dash. P total now after 2, that is 20. So not 8. Comes out to be x dash is comes to is every time it is halved. It follows which kinetics? 18. 18 plus 2, 20. Last time it was 4, 8, 0, 4, 12, 2, 18. So it follows first order kinetics that we come to know. That means 4 minutes means how many half lives? Four half lives. Amount left after 4 half lives is pressure of x after 4 half lives. So pressure of x after 4 half life is P naught by 2 raised to power n, n half lives, 2 raised to power 4. P naught was 8 divided by 16. That means it comes out to be 1 by 2. After 4 half lives, pressure of x 1 by 2. That means x to 3y, it is after 4 minutes is P naught minus x double dash, and it is 3x double dash. P naught minus x double dash is half. That implies x double dash is naught minus half. Is 8 minus half means is 7.5. That implies it is 0.5 and it is 7.5 into 3. Is 2.5. Point five. That means total pressure after 4 minutes, that is equal to 0.5 of x, 22.5 of y. It comes out to be 23 atmosphere. That means first option is correct. P1 is 23 atmosphere. Now total pressure on completion of reaction will be 24. Just tell me, is it true or false? I know you are talking about that reaction cannot be completed, or first order reaction it takes infinite time. But after infinite time, when reaction completes, you know, it is x to 3y 8, 0. So after completion of the reaction, whole of the x is consumed. According to me, if reaction is complete, it takes infinite time. But let us think if it is completed after infinite time, then whole of the X is consumed. So how much amount of Y is formed? Okay, got it? It is not written that how much time it takes. It takes infinite time. But if reaction is completed by any means, then on completion of the reaction, what is the total pressure of the mixture? Because when reaction is completed, whole of the reactant is consumed, and that is only 8 atmosphere. Whole X is converted into Y. 1 mole of X gives 3 moles of Y on completion of the reaction. Total pressure comes out to be 4 atmosphere. Okay, third option, is it correct? Partial pressure of Y will exceed that of X in less than 1 minute. See, even after 1 minute, the X becomes 4 and Y becomes 12. Obviously, partial pressure of Y exceed that of X in 1 minute. Right? Partial pressures of X and Y will be equal when the total pressure is 12 atm. Let us see X dy P naught minus X dx. So P naught minus X equal to 3x. This is the condition. Partial pressures of X and Y equal, the total pressure is 12. So in this way, 4x is equal to P naught, X is naught by is X. Now total pressure is pressure due to X plus pressure due to Y, comes out to be P naught plus 2x. Now P total is given as 12, P naught is 8, 2 into X is naught by 4. That means 12 is equal to 8. Just put here X is 2, eight plus 4. That means left side, right side are equal. Total pressure comes out to be 12. We have calculated that P total is equal to 12. That means partial pressures of X and Y be equal when total pressure is 12. All the 4 options are correct. Correct statements are A, B. All the statements are correct. Yes, this is very simple question. Do it. One of the following plots is correct. Which option is correct, and what is the order of the reaction first? Order See the unit of rate constant. Yes, it is 0 order 3 into 10 mole per liter per second. It is 0 order reaction. Zero order reaction. Option A. Any other option? One option. Which one? Calling plots. Plots. Also for yes, A option is correct because all other options are for first order. Natural log of R versus T, exponential is R is equal to R naught e raised to power minus KT, right? One log of R naught by RT to KT. All others are for first order. Only one option, first one, because it is R equal to R naught minus KT. Option A is okay. A patient receives the drug X 100 milligram intravenously. The concentration of the drug in the blood measured at 1 and 8 hours after the dose are 9 milligram per liter and 3 milligram per liter respectively. If the decrease in the concentration of the drug follows, if it follows first order kinetics, what is rate constant? Correct? First order kinetics and dose of the drug is administered. X is 1 milligram per liter. The next dose of the drug should be given after 14 hours. See, if it is zero order reaction, if next dose of the drug is to be administered when X is 1 milligram per liter, after 12 hours, then the initial dose to be 7.3 milligram. He is first order kinetics and half life of the drug is 4 hours. See, when we administered 100 milligram, we don't know the concentration. Okay, because it is not given per liter or. But when concentration of the drug after 1 hour, we know the concentration, that is 9 milligram per liter. Means after 1 hour, concentration is 9 milligram per liter. After hello. After 8 hours, concentration is 3 milligram per liter. So these are the two values given. After time is 1 hour and then time is 8 hours, and concentrations are given 9 milligram per liter, 3 milligram per liter. So if decrease in the concentration of the drug follows, let us say first order kinetics, follows first order kinetics, E1 8 let. 1 is equal to what? 80. Is 1 because you know Ct equal to naught minus 80. Yes, it follows first order, so natural log. That means Ct equal to E naught e raised to power minus 80. One is equal to naught e raised to power minus k only. E8 is equal to naught e raised to power minus 8k. These are the two equations. One is 9, 8 is 9 equal to naught for k naught for minus 8k. Two equations. Calculate k. Raised to power minus k divided by power minus 8k 2 by 3 e raised to power plus 8. Natural log on both sides. 7k log of e, natural log of 3. Guys, k is natural log of e is 1, a equal to log of 3 by 7. The value 0.3 a by a comes out to 0.3 still, but log 3 and 471 divided by 7. Tell me what is, and log 2 is 0.3, log 3 as 0.48, log 5 take as 0.7, log 7 is k. Is 0.157 per hour. So it is very close, round about same. And for D option, T half is 0.693 upon T half upon K is 0.693 divided by 0.157 or 156, take it. It is 4, almost. That means option A and D are correct. Now, if it is 0th order reaction, for 0th order reaction, you know, relation used is T equal to E naught minus KT. After 1 hour, 1 E naught after 8 hours. One hour it is 9, right? After 8 hours it is 3 equal to naught minus 8k. E naught minus k equal to 9. E naught minus 8k equal to, here you can calculate k, check them. 9 minus 3 6 equal to 7k. Guys, k comes out to be by 7. Is by 7 mole per liter per milligram per liter. Now next step is per liter per hour. Next step is next dose. If the next dose of the drug be administered, then X is 1 milligram per liter after 12 hours. Initial dose we administered 11.3 milligram. In this case, if you after 1 hour 9 naught minus k, k is by 7. What is C naught here? 9 plus 6 by 7. What is the value of C naught? 9.86, right? Then after 1 hour it turns into 9. After 8 hours it turns. Now he said the 0th order take initial concentration as 11.3 milligram. So much time it takes to 1 milligram, that we have to calculate, and according to him if it is 12 then this option is correct. K remains same because reaction is 0 order, so K, from these two statements we have calculated K. So you know Ct equal to C naught minus Kt. E is equal to E naught minus Ct by K. E naught is given as 11.3, is 1 divided by 7. So is 10.3 into 7 by 6. What is the value? 12. That means it's correct. B option is also correct. Just calculate for B. First order kinetics. Next dose X is 1 milligram per liter, and next dose of the drug should be given at 14 hours. This is K. Time 1 upon K, natural log of naught by dt. Time 1 0.156, natural log of, let's take initial as 9. And it is after 1 hour, so we have to add 1 hour in the time. We start counting after 1 hour. 9 divided by 1. What is the time? Natural log of 9 upon 0.156. And 1 hour, but we have counted after 1 hour, means total time taken is 14.1 plus 1 is 15.1 hour. Got it? Because after this 9 is taken as C naught and it is measured after 1 hour. Time taken to convert 9 milligram to 1 milligram is 14.1 hours. But it is started 1 hour before, because it is intravenously given by the patient 1 hour before the time count starts. That's why it should be 15.1 hours. So that means E option is तो यहाँ तक रखते हैं. This question is from NEST exam only. So why this concept? I will take up class tomorrow morning.